Oh, really?
All right, so on your homework, you guys talked about something that we're going to call limits. So on the homework that you guys have, I guess it's due tomorrow. Some of you guys have started it. You talk about what happens as you approach x equals 4. So you might start at 3.5 and then put in 3.9 and then 3.99, 3.999. So you just want to get closer and closer to a certain value. Okay, so that's called a limit. So you're getting closer and closer to a certain value. All right, so back in Algebra 2, pre-calc, you might have heard the phrase average rate of change. Has anybody ever heard that? Average rate of change? No? Okay. Average rate of change, you'll see this question a lot in AP Calculus. All it is the slope between two values. So average rate of change of f of x is just going to be f of b minus f of a all over b minus a. So it's the slope between x equals a and x equals b. I'll sometimes abbreviate it as ARC, average rate of change. So here's where you use something like that. So suppose I drop a rock from the top of a building that is 80 feet tall. The equation of the height of the rock would then be given by h of t equals 80 minus 16t squared. So if you don't know that formula already, if you take physics, you'll know that very well. Okay. If you want to find the average velocity, so the velocity is the change in the height per unit time, right? So the average velocity from 0 to 2 seconds, you would compute the height at 2 seconds minus the height at 0 seconds divided by 2 minus 0. Okay, so that's the average velocity. Average velocity is an average rate of change. It's the rate of change that the height is changing per second. Obviously, my answer's units would be what? Feet per second. Good. The reason that should be obvious is because h of 2 minus h of 0, those were heights. That was in feet. 2 and 0, those were seconds. So feet per second. But here's the hard part. What if you wanted to find the exact speed at 2 seconds? Okay, that's a little bit harder. You need what we call limits. Basically, you need to create an interval. So from 2 seconds to a little tiny bit more than 2. So 2 plus h, where h is very, very small. Then you repeat the process. So you would do like, okay, between 2 and 2.1 seconds, 2 and 2.01, 2 and 2.001. And you just keep getting smaller and smaller. And then you'll see that the velocity goes towards a certain value. So in this case, we're going to leave h in it. So we're going to say, what is f of 2 plus h? Oh, it's h, isn't it? That's annoying that I did h and h, but we'll go with it. H of 2 plus h minus h of 2 all over 2 plus h minus 2. I'm using h because h was my height after 2 seconds. Yeah. So h of 2 plus h means in your h of t formula, you're going to plug in 2 plus h in for t. So you're going to have 80 minus 16 times 2 plus h squared. Then you're going to subtract out h of 2. Can anybody do h of 2 in their head? 2 squared is 4, times 16 is 64. 16, right. All over, what's the denominator? H. Equals, we're going to go ahead and FOIL everything out. Multiply in, so I get 80 minus 16 times, when I FOIL, it's going to be 4 plus 4h plus h squared. Oh, minus 16. Ran out of room. All over h. So it's 80 minus 64 minus 64h minus 16h squared minus 16 all over h. 80 minus 64 minus 16? 0. Those go away. Good. So I now have negative 64h minus 16h squared all over h, which is negative 64 minus 16h. The h now goes in. So here's the interesting thing about what we just did. We said we're finding the limit as h goes to 0, so as h gets very, 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 very tiny. So we'd like to be able to just plug in 0 for h. We'd like to say at exactly 2 seconds. Okay? But in the original, you can't plug in 0 because you have divided by h. So see if you guys plugged in 0, you would get undefined. The top would be 0, the bottom would be 0. They'd be undefined. So what we've now done is you have multiplied everything out and manipulated it in such a way that the h's go away. The h in the top factors with the h on the bottom. Okay, now think about it. As h gets very, 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 very tiny, so 0.0001 or 100 zeros 1, what's it close to? What's that number right there that we have close to? Negative 64. So as h gets tinier and tinier, our velocity, our average rate of change, gets closer and closer to negative 64. You guys see it? Okay. So that's what it says. It says, then we say, but h is very, very small. So what if it was 0? In the original, if you plug in 0, you get undefined. But in this simplified version, you can plug in 0. And your answer is negative 64. That's your average rate of change. It's in feet per second. Why is it negative? Yeah, you dropped it off the top of the building. It's negative. It's going down. All right, so let's do another one. Suppose we have the function f of x equals x squared minus 4 all over x minus 2. Okay, if you plug in 2 right now, what happens?
Undefined.
Yeah, 0 over 0, right? Undefined. So let's find the limit. So you can, on your calculator, under y1, put in x squared minus 4 in parentheses divided by parentheses x minus 2. Okay, then you're going to go to table, so second table. Remember, if it doesn't allow you to choose your own values, you have to go to table set, and you have to make it so your independent variable is ask. So I'm going to put in 1, 1.5, 1.9, and so on. When I do that, I'm getting 3, 3.5, 3.9, 3.99, 3.999. Did you guys all get those values? Sure. Okay, now do 3, 2.5, 2.1, 2.01, 2.001. When you do those, you get 5.0, 4.5, 4.1, 4.01, 4.001. Okay. It's clear that the limit is most likely 4. That's right, Tarek's right.
Yes.
Okay. What does this from the left and from the right mean? So basically, if I had a number line and I had 4 on it, or not 4, 2, that's the x value I'm approaching. If I start at 1 and I start plugging in values, you see it right here, closer and closer to 2, which direction am I coming from if I start at 1 and I go to 2? The left, right. This is the left. So from the left. Okay, if I start at 3 and I get closer to 2, if I go this way, that's going to be from the right. Okay, and that will be very important because we're often going to talk about what happens from the left and from the right. Okay, now question, why does this graph look like a line? So I had f of x equals x squared minus 4 over x minus 2. Why does that look like a line? Because it is a line, is that what I heard?
Yeah.
When I look at it, I'm like, shouldn't there be a vertical asymptote? Why isn't there a vertical asymptote? It cancels, right. So you have x plus 2 times x minus 2 all over x minus 2, and the x minus 2's cancel. In other words, if you remember from Algebra 2, that's a hole. There's a hole at x equals 2. It's a value that originally made your function undefined, So if you plug in 2, you get 0 to 0. But it cancels. So if you factor, it cancels out. All right, so that means it looks like whatever's left, the x plus 2. So it looks like y equals x plus 2 with a whole at x equals 2. That's exactly what you have. That's the line we have. Y-intercept is 2, up 1, right 1, up 1, right 1. Okay. Notice as you approach from the left and the right, what is this y value right there? 4. That's what we just found. So you can do the limit argument or you can do the sketch and you would find the same thing. Your y value is getting closer and closer to 4. All right, next up. So definition of a limit. This is the main definition of a limit. This is in every calculus book ever. It's confusing. It uses words like sufficiently and arbitrarily. But basically, we've just talked about what a limit is. So it says we write the limit as x goes to a of f of x equals L, and say the limit of f of x as x approaches a equals L, if we can make the values of f of x arbitrarily close to L, so as close as you'd like it to be, by taking x to be as close as you need it to be, sufficiently close, on either side but not equal to itself. Confusing? So it's saying if you have a limit, you don't have to draw this. We say that the limit approaches a certain L value, so a certain y value there, as you get closer and closer to a certain x value, so x equals a. So as I go towards a from the right and the left, I'm getting closer and closer to that y value. So it's going there and going there. See how they're both getting closer and closer to that value. Now it doesn't actually have to equal L. Notice how I have an open circle? You know, the actual point could be somewhere else. I could have a filled in point above it. But the limit is approaching that. Okay. I always think if I zoom in on that point, so if I zoomed in right there where I circled, the closer and closer that I get, all of your points are lining up and looking like they're going to that same point. Do you see what I'm saying? Kind of confusing with limits at first. Okay, sometimes you might see f arrow L as x arrow a, which is usually read f of x goes to L as x goes to a. So it says, notice in our definition of the limit, we made the distinction that x doesn't have to be equal to a. You'll see why in this next example. So let's sketch out this piecewise function. So it says, find the limit as x goes to 1 of g of x for our piecewise function. All right, so when you guys see g of x equals x minus 1 over x squared minus 1, what do you think about doing to that function?
Factor to the bottom.
Factor the bottom, right? So you're going to factor into x plus 1, x minus 1. X minus 1 is on top. X minus 1's cancel, so you get 1 over x plus 1. 1 over x plus 1 is something we know how to graph. There's a vertical asymptote. What's the vertical asymptote?
-1.
Yep. Good thing you guys did that summer project there. Horizontal. It's a shortcut. 0x over 1x, so it's 0. So y equals 0. All right, so here's what the graph looks like. At -1, you have a vertical asymptote. At 0, you have a vertical asymptote, or horizontal asymptote. You can try some other points. If I try 0 and I plug in 0 to the simplified version, I have 1 over 0 plus 1, so 1. So we have a point there. If you plug in 1, you get 1 comma 1/2. If I plug in 2, I get 1 comma 1/3. So basically it's getting smaller and smaller and it's getting closer and closer to the asymptote. So it looks like that. If you plug in anything on the other side of -1, so if I plug in -2, I'm getting a negative answer out. So it's one of those that looks like this. kind of like 1 over x. Okay, but notice it's a piecewise function. So it says, yes, we have that function we just graphed if x is not equal to 1. And then it says, if x is equal to 1, then your y value is 2. So at 1, we have an open circle. Ooh, I drew mine way above the line. So open circle right there. And then the y value is actually 2. So you're going to fill in above. Does that make sense to everyone? Yes. So it looks like 1 over x. It's just been shifted left 1. We don't include x equals 1, so we do an open circle. And we have the point 1, 2. When x is 1, y is 2. All right. So the question is, what is the limit as x goes to 1? So from the left and right, what number am I getting closer and closer to? So I'm going to trace along the curve, and I'm going to get closer to x equals 1. So I'm going to go this direction. What y value am I getting closer and closer to? 1/2. That's right, Tim. How'd you get 1/2?
I said negative.
Yeah. I thought you were right up there. He said negative 1. All right, it's 1/2. Okay, do you guys see why it's 1/2? What was our simplified function? 1 over x plus 1. What happens when you plug in 1? You get 1/2, right? So both of these are getting closer and closer to this open circle that I've drawn in. That open circle is the point 1, 1/2. But it's not included in our graph. It was open. But what a limit is it doesn't matter if it's open or closed. It's just saying as you keep getting closer and closer to 1. So if I did 1.1, I'm really close to 1/2. 1.01, I'm even closer to 1/2. Do you guys see? As I go from the left to 0.9, 0.99. You're always getting closer and closer to that open circle. So the limit as x goes to 1 of g of x is equal to 1/2. So I don't care where the other point was drawn in. I could have had this filled in circle up at 500. I don't care. It doesn't matter. The limit is getting closer and closer to 1/2. All right, so let's see if we can do some more of these. Okay, show that the limit of the Heaviside function, so the limit as x goes to 0 of the absolute value of x over x does not exist. Okay, so let's think about it. Let's do a t-table. Okay, what if I plug in 2? Absolute value of 2 divided by 2, what's it going to be? 1. 3?
It'll be the same for everything.
It's always 1?
Yeah.
When is it not 1?
Negative.
-2, right? Then it's positive over negative, it's -1. So it's always 1 or -1. That's what you guys are thinking?
Zero, it's 0.
Except when it's 0, right? So here we have 1 and -1. So it looks like that for all positive numbers. It looks like, well, not slanted down like mine was. It looks like that for all negative numbers. And at 0, what's happening at 0? You guys are so quiet. What? Nothing. It's undefined, right? Nothing's happening at 0. Because if we have 0 divided by 0, undefined. All right, I always thought this was called the Heaviside function because I was like, oh, the left side's heavier than the right side, so it's down lower. No, it's called the Heaviside function because a guy named Heaviside came up with it. So I thought it was ironic. So why does this limit not exist? So as I get closer and closer to 0 from the right, so if I'm going along the right, what's my y value getting closer and closer to? It can be open. What y value? 1. As I go towards 0 from the left, so I'm going this direction, it's -1, right? In order for the limit as x goes to 0 to exist, both from the left and the right have to go to the exact same value. So you can have things where you have a curve and it's open circle, but both went to that same value, you know. But you cannot have where there's some kind of like jump. They have to go to the same value. All right. In a little bit, we're going to talk about left-hand limits and right-hand limits, so you'll see what I mean by that. Okay, show that the limit as x approaches 1 of the greatest integer function does not exist. Greatest integer function, take off the divided by x. I don't know I had that. In Algebra 2, we called it was like a fancy bracket. That's the same as what your book notates as int x, integer x. And all that is the greatest integer less than or equal to x. Okay, so if I have 2, what's the greatest integer less than or equal to 2? 2. 2.1, what's the greatest integer less than or equal to 2.1? 2. So basically everything's always going to round down. 2.6, greatest integer less than or equal to 2.6 is 2. So it's always going to round down to the integer below it. Okay, so here's what happens on your graph. If I'm between 0 and 1, it's always rounding down to 0, right? So it's going to be this flat step there. If I'm between 1 and 2, it's going to round down to 1. So it's going to be there. If I'm between 2 and 3, it's going to round down to 2. See how it's making these little steps? It's also called the step function. Okay, if I'm between -1 and 0, what's it round down to? -1. So it just makes these little steps. Okay, what about the endpoints? Closed where? Left or right? Closed on the left, because if I was at 1, the greatest integer less than or equal to 1 is itself 1. If I was at 2, the greatest integer less than or equal to is 2. So fill in the left ones. And then we have open circles on the right, because it's everything up to, you know, if I was on 1.9999999, that's still rounding down to 2, or to 1. I'm going to really mess you up. All right, there we go. So this is it. So why does it not exist? Yeah, left and right don't go to the same thing. So as you go to 1, this would be the right one. Here's x equals 1, right? So as I go from the right, I'm getting closer to y equals 1. As I go from the left, I'm getting closer to y equals 0. So right limit is 1, left limit is 0. All right, we're going to finish these up real quick. All right, left-hand and right-hand limits, they're fancy notation. Do you guys see them? Yeah. Questions? No. Let's ask. That's okay. All right, see how it says x goes to a from the negative? Okay, negative numbers, what side are they on? Left. So whenever you see a is negative, that means coming from the left, getting closer to a. It doesn't matter that a is not a negative number. It's just saying getting closer to a. So if I wanted to talk about what happens as you go towards 2 here, 2 from the left would be going towards 2 from this direction, 2 negative. If I wanted 2 from the right, I'd go 2 positive. It's the exact same definition before, it's just left and right. It's not too bad. Limit as x goes to a of f of x equals L if and only if the right-hand and left-hand limits are exactly the same. Okay, so right and left-hand limits have to be exactly the same. So here's how you write right-hand and left-hand limits. So limit as x goes to a from the left. So this is left. Equals limit as x goes to a from the right. They're all going to be equal to L, that y value. Okay, so I'm going to do the first couple, and then you guys are going to try the other ones. So 1a says limit as x goes to 0 from the left. See how you have the negative sign? It means from the left. So that means you're going towards 0. So x equals 0. So I'm going in towards 0, in towards 0. What's the y value you hit? 3. This is equal to 3. Okay, limit as x goes to 0 from the right. So in towards 0, tracing, 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 in towards 0. What's the y value you hit? 1. I'm going to confuse you with my colors. I switched them up. 3, 1. All right. So what is the limit as x goes to 0? Does not exist. D and E. Because the right and left have to go to the same thing in order for 0 to exist. Does not exist. They went to 3 and 1, so this one does not exist. Now that doesn't mean that all of them are always D and E for the ones that don't have a plus or a minus.
Why is it x goes to 0 then?
Because as you're going to 0 from the left and the right, you're not connecting. You're not going to the same point. Okay, think about the next one. So 5 from the left. So here's where 5 is. So 1, 2, 3, 4. So as I'm getting closer to that line there, from the left, what y value are you hitting? 3. Is that the same as 5 from the right? Yeah, they're the same. So that means the limit as x goes to 5 would be 3. Okay, next one. So as I approach -2, so here is -2. As I approach, it says from the right or left, right? Right and left, do they go to the same value? 3. All right, 1 from the left. 2. Why is it not 6? Good question. That's not what the graph is. It's not the limits. It's what f of 1 is equal to. So question down here, it says what is f of 1? F of 1 is equal to 6. That's where it's filled in, x equals 1. That's the point that's filled in, right? So that's not the limit. Limits are what you get closer and closer to.
So how do we find f?
Okay.
I'm so confused.
Okay, next one. So x approaches.
No, wait. I mean, like, how did we get letter f? Like, how is that 2?
Oh, letter F?
Yes.
Okay, F is 2. Okay, gotcha.
Sorry.
Because as I go from the, I can't even see mine anymore, it's so tiny. So as I go from the left to 1, so here's where the line 1 is.
Oh, I
So
see.
from the left, you're going closer and closer to the y value of 2.
Okay.
All right, next up. What do you guys think? So 1 from the right?
Same.
Still 2, right? Next one, so limit as x approaches 1, since they're the same, it's 2. Limit as x goes to -3? 1. Do you guys agree that it's 1?
Yes.
Yeah, because here's -3. It's going to 1. Limit as x goes to 3? 1. Also 1. Okay, do you guys understand?